In this session, we will discuss the structure of a C program, character set, tokens, data types, variables, operators, input and output statements, and control statements. What is C programming language? C is a general purpose programming language developed by Dennis Ritchie in the year 1972 at Bell Laboratories. It is considered a middle level programming language because it combines features of both high level and low level languages. C allows programmers to write efficient and fast programs while also providing access to low level memory manipulation using pointers. It is widely used in system programming, operating systems, embedded systems, and application development. One of the main reasons for the popularity of C is its portability, meaning programs written in C can run on different machines with little or no modification. It also provides a rich set of operators and built in functions, making it powerful and flexible. Structure of a C program. Every C program follows a specific structure. The program usually begins with the documentation session, where comments are written to describe the purpose of the program. Next comes to the link section, where header files are included using the hash include directive. Header files like stdio.h provide input and output functions such as printf and scanf. After that, we may have the definition session where constants are defined using the hash define preprocessor directive. Then comes the global declaration section where global variables and function prototypes are declared. The function is the most important part of any C program because execution always starts from the main function. Inside the main function, we write the executable statements of the program. Finally, user-defined functions can be written outside the main function if needed. This structured format makes C programs organized and easy to understand. Character set in C. The character set in C refers to all the valid characters that can be used to write a C program. These characters are used to form words, numbers, expressions, and statements. The character set includes alphabets from A to Z and small letter A to Z, digits from 0 to 9, special symbols like plus, minus, multiplication, division, percentage, brackets, braces, semicolon, and many others. It also includes whitespace characters such as space, tab, and new line. These characters together form the building blocks of C program. Without understanding the character set, we cannot properly write identifiers, constants, and expressions. Tokens in C. Tokens are the smallest individual units of a C program. When a C program is compiled, the compiler breaks the program into tokens for analysis. There are different types of tokens in C such as keywords, identifiers, constants, operators, special symbols, and strings. For example, in the statement int a equals to 10 semicolon, each word or symbol like int a equal sign 10 and semicolon is considered a token. Tokens help the compiler understand the structure and meaning of the program. Understanding tokens is important because they form the basic elements of every C program. Keywords in C. Keywords are reserved words in C that have predefined meanings. These words are part of the language syntax and cannot be used as the variable names or identifiers. Examples of keywords include int, float, if, else, while, for, return, break, and continue. All keywords are written in lowercase letters. Each keyword performs a specific function. For example, the keyword int is used to declare integer variables, while if is used for decision making. Since keywords have special meaning to the compiler, they must be used correctly in the program. Identifiers in C. Identifiers are the names given to variables, functions, arrays, and other user defined elements in a program. They help us identify different entities in the program. There are certain rules for naming identifiers. An identifier must start with a letter or an underscore. It cannot start with a digit. Special characters except underscore are not allowed. Keywords cannot be used as identifiers. Identifiers are also case sensitive, which means uppercase and lowercase letters are treated differently. For example, total and capital total are considered two different identifiers. Choosing meaningful identifiers improves program readability. Data types in C. Data types in C specify the type of data that a variable can store. They determine the size of memory allocated and the range of values that can be stored. The basic data types include int for integers, float for decimal numbers, double for large decimal numbers, and char for characters. C also provides derived data types such as arrays, pointers, stretchers, and unions. Additionally, there is a void data type which represents the absence of value. Selecting the correct data type is very important because it ensures efficient memory usage and accurate results in computations. Variables in C. A variable is a named memory location used to store data. Before using a variable, it must be declared with a data type. For example, when we declare int age, the system allocates memory to store an integer value and associates it with the name age. The value stored in a variable can change during program execution, which is why it is called a variable. Variables help in storing input data, performing calculations, and displaying output result. Proper declaration and initialization of variables are important for avoiding errors in the program. Operators in C. Operators are the symbols used to perform operations on variables and values. C provides various types of operators. Arithmetic operators such as plus, minus, multiplication, division, and modulus are used for mathematical calculations. Relational operators like equal to, not equal to, greater than, and less than are used to compare values. Logical operators such as and, or, and not are used to combine conditions. Assignment operators are used to assign values to variables. There are also increment and decrement operators used to increase or decrease a variable's values by ones. Understanding operators is essential for writing expressions and performing computations. Operator precedence. Operator precedence determines the order in which operations are performed in an expression. When an expression contains multiple operators, the operator with highest precedence is evaluated first. For example, multiplication and division have highest precedence than addition and subtraction. Parentheses have the highest precedence are used to control the order of evaluation. Understanding operator precedence is important to avoid logical errors in calculations. Input and output statements. Input and output operations in C are performed using standard library functions provided in stdio.h. The printf function is used to display output on the screen, while the scanf function is used to take input from the user. These functions are used format specifiers such as %d for integers, %f for floating point numbers, %c for characters, and %s for strings. Input and output statements allow interaction between the user and the program, making programs dynamic and user friendly. Control statements in C. Control statements are used to control the flow of execution in a program. Decision making statements such as if else, and switch allow the program to choose between different paths based on conditions. Looping statements such as for, while, and do while allow a block of code to be executed repeatedly. The break statement is used to terminate a loop immediately, while the continue statement skips the current iterations and moves to the next one. Control statements make programs flexible and capable of solving complex problems. An array in C. Explain with the types. An array in C is a collection of elements of the same data type stored in contiguous memory locations. It is used to store multiple values under a single variable name, making the program more efficient and organized. Each element in an array is accessed using an index, and indexing always starts from 0 in C. Arrays are particularly useful when handling large amounts of related data such as marks of students or a list of numbers. There are different types of arrays in C, mainly single-dimensional arrays and multi-dimensional arrays. A single-dimensional array is used to store elements in a linear form, whereas multi-dimensional arrays such as two-dimensional arrays are used to represent data in tabular form like rows and columns. Arrays help in reducing the complexity of programs and improve code readability. Define and explain single-dimensional array. A single-dimensional array is the simplest form of array in C and is used to store a list of elements of the same data type in sequential order. It is declared by specifying the data type followed by the array name and size enclosed within square brackets. For example, int marks of 5 declares an array that can store 5 integer values. The elements are stored in continuous memory locations and each element can be accessed using its index number starting from 0. Single dimensional arrays are commonly used in programs that require storing multiple values such as student marks, temperatures, or numerical data. Initialization of arrays can be done at the time of declaration or later during program execution. Explain array initialization and accessing elements. Array initialization refers to assigning values to array elements at the time of declaration. This can be done by providing a list of values and rows within curly braces. For example, int a of 3 is equal to set of 10, 20, 30. Initializes the array with 3 elements. If favored values are given, the remaining elements are automatically initialized to 0. Accessing array elements is done using the index number inside square brackets. For example, a of 0 accesses the first element. Since arrays are stored in contiguous memory, accessing elements is very fast and efficient. Proper indexing is important because accessing invalid indexes may lead to unpredictable results. Explain two-dimensional array. A two-dimensional array is an array of arrays and is used to represent data in tabular form consisting of rows and columns. It is declared using two size specifications inside square brackets such as int matrix 3 3, which creates a 3 into 3 matrix. Two-dimensional arrays are commonly used in applications like metric operations, tables, and grids. The elements are stored in a row major ordering memory. Each element is accessed using two indices, one for row and one for column. For example, matrix 1 2 refers to the element in the second row and the column. Two-dimensional arrays make it easier to perform matrix addition, multiplication, and other mathematical operations. Write a paragraph on programs for matrix processing. Matrix processing in C involves performing operations such as addition, subtraction, multiplication, and transpose on two-dimensional arrays. These operations are performed using nested loops because a matrix contains rows and columns. For example, matrix addition requires corresponding elements of two matrices to be added and stored in a result matrix. Matrix multiplication involves multiplying rows of the first matrix with columns of the second matrix. These programs help students understand nested loops and multidimensional arrays effectively. Matrix operations are widely used in engineering, graphics, and scientific computations. Explain sequential search. Sequential search, also known as linear search, is a simple searching technique used to find an element in an array. In this method, each element of the array is compared with the targeted value one by one until the element is found or the end of the array is reached. It is easy to implement and does not require the array to be sorted. However, its efficiency is low for large data sets because it may require checking every element in the worst case. Sequential search is suitable for small arrays or unsorted data. Explain bubble sort. Bubble sort is a simple sorting technique used to arrange elements in an array in ascending or descending order. In this method, adjacent elements are compared and swapped if they are in wrong order. This process is repeated multiple times until the array becomes sorted. The largest elements bubbles to the end of the array in each pass. Hence the name bubble sort, although it is easy to understand and implements. Bubble sort is not efficient for large data sets because its time complexity is high. It is mainly used for education purposes to understand sorting logic. What is a string in C? A string in C is a collection of characters stored in a character array and terminated by a null character. Strings are used to store text such as names, messages, and sentences. Unlike other programming languages, C does not have a built-in string data type. Instead, strings are represented using character arrays. For example, char name of 10 can store a string of up to 9 characters along with a null character. Strings can be read using scanf or gets functions and displayed using printf or puts. The null character is important because it indicates the end of the string. Explain string handling functions. C provides several built-in string handling functions in a string H header file. These functions simplify string operations such as copying, concatenation, comparison, and length calculation. For example, strlen of is used to find the length of the string. Strcpy is used to copy one string to another.
strcat is used to join two strings, and strcmp is used to compare two strings. These functions reduce manual coding effort and make string manipulation easier. String functions are widely used in applications that involve text processing. Explain string matching. String matching refers to comparing two strings to check whether they are equal or to find the occurrence of one string within another. In C, string matching is usually performed using the strcmp function. If the function returns 0, it means the strings are equal. String matching is useful in applications like password checking, searching words in a sentence, and validating user input. Proper understanding of string matching is important for handling text based data efficiently.